Hi all, welcome to the new video of we are going to discuss about implementation of queue using array. Last class we discussed the concepts of queue data structure. Queue is a linear data structure, and the principle followed by queue is first in first out. First inserted element will be deleted first. Okay, now we are just discussing about the procedure before insertion and the procedure for deletion and all. Okay, here we are going to discuss about how the process is going on. So in the case of insertion, the first step is to verify whether the queue is full or not. If the queue is full, then we can insert a new element. If the queue is not full, then we are going to verify whether the queue is empty or not. Okay, so I am explain the thing with the help of a simple example. Here I am going to insert a new element here. So the user will choose the option 1 for insertion. At the time of inserting an element, we are going to verify whether the queue is full. How to verify the queue is full? Verify the because insertion can be performed in the rear end and deletion can be performed in the front end. That is the procedure. So insertion can be performed in the rear end and deletion can be performed in the front end. So I am using the variables front and rear to identify the status of the queue. In this case, before insertion, I have to verify whether the queue is full. For verifying whether the queue is full, I am using the variable rear. In this case, rear value is -1. So what will be the condition if the queue is full? For example, I inserted the value 10 here. The front value is incremented by 1. Listen, in this case, the queue is initially empty. So at the time, after the insertion of first element, we have to modify the value of both the rear and front to 0. Then only the process will continue properly. Okay, so after the insertion of 10, the value of front equal to 0 and rear is also 0. After the insertion of element 20, front remains 0, but rear is incremented by 1, so rear equal to 1. And again, I am inserting a new element 30. Front value remains the same, rear value equal to 2. Okay. Now I am going to delete an element. So the only possible element for deletion is 10, because first in first out, the first element will be deleted first. So I am deleting the element 10. So after deletion, I am incrementing the value of front alone, because front represents the first inserted element. So after the deletion, front will be moved to the next available first inserted element. So front is representing the value 20. Again, I am inserting a value 40. Rear equal to 3. Again, I am inserting a value of 50. Rear equal to 4. In this case, we don't have an empty space here. After 50, we don't have an empty space. So in this case, the queue is full. Even after we are having an empty space in the 0th position. So this is a disadvantage of a linear queue that we will discuss in the future classes. So in our case, we have rear value is in the rear represents the fourth position, and we don't have any empty space after 4th position. So how will we verify whether the queue is full or not? If rear equal to maximum size of the array -1. What's the maximum size of the array -1? Maximum size of the array is 5. 1, 2, 3, 4, 5. 5 elements can be accommodated in this array. So the maximum size of the array is 5, and rear value equal to 4. So if 4 equal to 5 minus 1. So if the condition is true, then we are saying sending an error message saying that the queue is full, even after we are having an empty space, but we can't accommodate, because insertion can possible only in the rear end. That is very important. That is why I am telling insertion can be performed only in the rear end, and deletion can be performed in the front end. Okay. Again, I am going to discuss the same one more time. Okay, initially the queue is empty. Okay, initially the queue is empty. We are going to insert a new element. So, first step. What is the first step? First step for before inserting an element, verify the queue is full. Okay, that we discussed. If the queue is full, print an error message. That also we understood. Third step, if the queue is not full, what is the meaning of that? If the queue is not full, then we have two options. The first option is the queue may be empty, or the second option is the queue may be partially filled. So two possibilities we have. So if both the possibilities, if the first possibility is there, if the queue is empty, then we have to make a separate procedure for that, because now we have an empty queue. After the insertion of first element, what we are going to do is we are going to increment the value of front and rear to 0. So initially the value of front equal to -1, rear equal to -1. After the insertion of the first element, what will happen? Front will be incremented by 1 and rear also incremented by 1. So -1 plus 1, 0. But after the insertion of first element, consider I am going to insert a second element. I am going to insert only the rear value. No, front value remains in the 0th position. So this is a special case. So after verifying the queue is full, if the queue is full, then print an error message. If the queue is not full, then we are going to verify. Two cases are there. We have to identify whether the queue is empty or whether the queue is partially filled. The first case is verify the queue is empty. Why we are verifying this? We have to increment, if the queue is empty, then we have to increment both the value of front and rear to 0, from -1 to 0. So if the queue is empty, increment front and rear value by 1. Then insert a new element. If the queue is not empty, increment the rear value by 1 and insert a new element. So this is a procedure. Okay. Now we are going to write a program for this. I am using an online compiler here. Last class we discussed about the main part of the program. Again I am going to discuss, because for clearing the doubts also. Some of the students may have doubts on how to write a program in the main part. So before writing a main part of a program, we just want to clarify what's going to display in the output screen. Okay. These are the statements that we are going to display in the output screen. Choose the following options. One for ENQ, 2 for DQ, 3 for display, 4 for exit. These are the four options that we are providing to the users. And if the user is choosing the option 1, then what will happen? NQ operation should be performed. Then if the after the NQ operation, again this statements like choose the following option, 1 for NQ, 2 for DQ, 3 for display, 4 for exit. All these statements has to be executed continuously until we press the option 4. So these are the cases. So in this case, I am going to write a program for that. What is the first statement that we have to print in the output screen? Choose the following option. So printf. printf choose the following options. Again, I am using one more printf to print the options one by one. /n, one for ANQ. Okay, then /n, two for DQ. Then /n, three for display. Then /n, 4 for exit. Okay. Let me check whether how this is displaying. Okay. Choose the following options. So I just made two statements here. I just write two statements here and just compiling the program. So by clicking on the run button, just verify whether the things are going in a proper manner. So 1 for NQ, 2 for DQ, okay, 3 for display, and 4 for exit. Okay, so we are getting it in a proper order, one by one. Okay, after that, what we are going to do is we are going to collect the value. For collecting that options, so what are the options? It may be 1, then 2, then 3, then 4. These are the options that we have. So all these are integer values. So we are going to collect the value in a variable. So scanf, integer in the sense the control string for integer is %d, then choice. So ampersand choice, ampersand in the sense address of choice. So what is the meaning of that? I am going to use a variable named choice, and I am going to store these values 1, 2, 3 or 4 in a variable choice. So before using the variable choice, I have to declare the variable choice in the declaration part of the program. Okay, scanf percentage of choice. We collected the choice. After collecting the choice, we have to use the switch case statement. Okay, switch, switch, switch off. So inside the switch, I place the variable choice because from switch case onwards, the process is getting continued. Process is going to get continued. Okay, in this case, what's the first case? Case 1. Okay, case 1. I'm just printing whether the program is working correctly. I just want to print NQ operation. To verify whether things are going in a planned manner. Okay, break. So this is a syntax of switch case statement. Okay, if the choice the user if the value provided by the user is 1, then it goes to the case 1. If the value provided by the option 2, printf DQ operation. Okay, break. What's the case 3? Case 3 for display. Printf display the elements in the queue. Elements in the queue. Okay, break. Case 4, printf exit the program. Okay, then break. Okay, we are going to verify whether the program is running in a planned manner. Okay, I am running the program. Okay, 1 for NQ, 2 for DQ, 3 for display, and 4 for exit. So I am going to give a value 1 here. So what's the expected outcome? Output, if the choice is 1, then it will store in the variable choice, and that will be moved to the expression switch of 1. Switch will identify which case is this from the variable choice. If the case is 1, then print NQ operation. If the case is 2, then print DQ operation. If the case is 3, then print display the elements in the queue. If the case is 4, then exit the program. So I am going to give a value 1 here. Okay, let me see. Okay, NQ operation. But the thing is, it getting okay. The program is exited. Okay, program finished with exit code 0. Okay, so this is not our plan. So I have to continuously run the same all the 4 statements and collect the values. After, based on the collection, then the program has get executed, get exit from the case. Okay, so I am going to run one more time to verify whether all the cases are executing properly. So I am using the value 2 here. Okay, DQ operation. Again I am running the program. Okay, 3 for display. Okay, display the elements in the queue. Okay, again I am running the program. Option 4, exit the program. Okay, as on now, that means as per the current program, it is working fine. Now I just want to repeat the statement until the programmer wants to, or until the user wants to exit the program. For that, what are the statement has to be continuously executed? The first statement, this one is needed. This one is also needed because these 2 statements are continuously going to get executed. Then scanf statement also needed because from the scanf statement only we can get the value for choice variable. So from this printf2, this closing brace is needed under a loop. So I am using a while loop here. While of what should be there inside while that we will discuss. Okay, so I am going to finalize what are the statements that has to be under the control of a while loop. So from this printf statement to this closing brace, so I aligned accordingly. Okay, what's the next step is to initially whatever it may be, initially first time while running the program, this while statement has to be true. So for making this condition initially true, I made it the value of I am verifying the value of x equal to 1. So before doing that, I just want to assign the value of x equal to 1 initially. So while verifying x equal to 1, condition will automatically get true because the value of initial value of x equal to 1. So automatically this condition will be true, and moving to the first, inside the program, this will execute completely. But after pressing the value exit, we have to change the value of x equal to 0 so that this condition will get false. Let me check. Okay, first I am going to put inside, press the value 1. Okay, NQ operation, choose the following operation. Listen, NQ operation, then continuously this is running. Okay, choose the following option. So I just want to make this one to the next line. So I am exiting the program for it. Okay, program is working fine. So I just want to make some arrangements like this. So /n. Let me check. Okay, whether the things are going fine. Okay, here choose the following options. Okay, 1 NQ operation. Okay, choose the following option again. It's asking for the second choice. choose the DQ operation, choose the following options. 3 I am giving, should, okay, display the elements in the queue. Okay, last I am running the I am trying to exit the program, X. Okay, what will happen? X, once we press the value X, then once we press the value 4, then inside case 4 will execute. What are the things inside the case 4? Printf exit the program. The second statement is x equal to 0. So automatically the value of x is changed to 0, and this condition where x equal to 0, value of x is changed to 0, so 0 equal to 1, the condition get false. So this is the initial part of the program. Next we are going to write a program for enqueue operation, dequeue operation, and display operation. So here I am writing the user defined function for enqueue. It's a calling function. We are going to call the function here enqueue. This is a user defined function, so that we have to declare this user defined function. This is a user defined function, not going to return any value and not going to send any parameter from main program to the subprogram. So if we are not going to return a value, then what we are going to do is we are assigning the return type as void enqueue, okay, enqueue. Inside the parameter, this is a parameter space. This is a space for parameter. So I am not going to use any parameter here. So I declared it like this: void enqueue void. Okay. Then after this one, after the main program, I am going to write a subprogram for this: void enqueue. So this is a subprogram. I am going to write a subprogram for this. Okay. In the subprogram, we need two more variables to verify the status of the queue. So what are those variables? I am going to declare those variables in a global declaration part. So int rear equal to -1, comma friend equal to -1. So initially these two values should be -1. Then only we can perform the insertion and the deletion, because this is the program. After each and every compilation, the value should be reassigned. Then only we can do the work. Okay, int rear equal to -1 and friend equal to -1. So what's the first step for before inserting an element that we identified? Enqueue, verify the queue is full or not. How will we verify? We have to declare an array for storing the value. So these are the two variables, int and rear and friend. One more array I am declaring here, a of. Okay, what's the size of the array? So that is that we have to define. Okay, hash that we discussed in the last class. This is a micro definition. Hash define max 5. So maximum size of the array, I declared it as 5. So in the entire program, the value of max will be 5. So I am using the max inside the declaration part of the array. Okay. After that, we are moving on to the enqueue program. Verify whether the queue is full or not. To verify, I am using for insertion we are using the variable rear, and for deletion we are using the variable friend. So as per the concept, friend end for deletion and rear end for insertion. So I am using the variable rear equal to maximum size of the array -1. If this is the case, we are going to say that printf queue is full. Okay. So further execution should not happen, because queue is full. We don't have any other option. just exit the program, or asking the user for the second option. Okay, if the queue is full, this is the case, else. Okay, listen, what we did is we create a program for this. If array equal to max minus 1, then we printed the value queue is printed as message queue is full. If the condition is false, then we have two options. First one, what is the first option? So this is a procedure that we created. Verify the queue is full, that we completed. If the queue is full, print an error message. That also, these two statements also, these two steps also that we completed in the program. What's the third case? If the queue is not full, then verify if the queue is not full, then we have two options. Verify the queue is empty. If the queue is empty, do the procedure for inserting an element in an empty queue, or we can perform the operation enqueue in a partially filled queue. So these are the two options. So first identify whether the queue is empty or not. So in our case, so the next step is to verify whether the queue is empty. How will we verify? If the queue is empty, friend value and the rear value equal to -1. But anyway, I am using variable friend equal to -1. If friend equal to -1, then we can confirm that our queue is empty. What's the procedure if the queue is empty? If the queue is empty, then we incremented the value of friend by 1, or we can assign friend equal to rear equal to 0. We are directly assigning the value because there is no other option for making either 0, either 1 or 2 or 3 or 4. We have only option to make the value of front and rear as 0. Okay, we are going to insert, because in this case, listen, in this case we have the only option. If the queue is empty, so this is an empty queue, front value equal to -1 and rear value equal to -1. In this case, after if we are trying to insert an element, the only available position for insertion is 0th position. So what we have to do, we have to make the value of front and rear to 0 and then insert a new element. So we have only one option. We don't have any other options to change. So I directly assign the value of front equal to rear equal to 0. After that, I am trying to collect a element, printf. Okay. Enter the element. We are collecting the element in the scan with the help of a scanf statement. Scanf %d, element ele. So ele is a variable declared, it should be declared. Okay, so I am storing the value in a int ele. Okay, declared. So element also collected. After that, we are directly inserting the element here. A of rear equal to ele. Okay, completed. So if the queue is empty, increment the value of a front and rear by 1, or a front and rear equal to 0. There is no other option for this. So front equal to rear equal to 0. We assigned it as like this, and then we are collecting the element, and that is stored in the variable ele. So that should be declared in the declaration part of the subprogram, because ele is a variable that we are going to use inside the subprogram, not in the main program or anywhere. That is why I mentioned it inside that is why I declared it inside the subprogram. This is a subprogram, this is a main program. So I mentioned it in the subprogram that int ele, and we collected the value in ele, and we directly insert the value because queue is empty. We completed the procedures like front equal to rear, rear equal to 0. We assign the value of front and rear as 0, and then inserted. If this is not true, that means if the queue is not empty, then we have only one option. else. What's the meaning of that? We don't want to verify the condition because we have only one option remaining, partially filled. Okay, if the queue is not full, then we have two options. One is queue may be empty or queue may be partially filled. We completed the procedure for empty queue while insertion. Next we are going to discuss about how to insert an element in a partially filled queue. So the procedure is increment the value of rear, because in this case now the queue is not empty, queue is a partially filled one. So after, in this case, if we are going to insert a new element, we just want to increment the value of rear and then inserting an element. So rear alone is going to get incremented. So I am incrementing the value of rear by 1, rear plus plus, then a of rear equal to ELE. Program is completed. Program is over. So we completed all those program, all the procedure in the NQ option. Okay, let me check whether the program is running correctly. Okay, there is an error. So I made a mistake that the spelling of a friend, FROND declaration part is correct, but okay, I made a mistake here. Okay, now I am again running the program. Okay, now it's working correctly. One for NQ operation, enter the element. Okay, enter the element. I am inserting the element 10 here. Okay, then it's, we assume that the program 10 is stored in the array. So I just want to verify whether it's working fine or not. Okay, how will we verify? I am just printing the value here. Print a of percentage d comma a of rear, or this is in the MD case, so we can directly mention it as a of 0, because if the queue is empty, then the value should be saved in a of 0th position, and so that is why I am verifying here like this. Okay, first option, enter the element 10. Okay, we entered the element here. Immediately after assigning the value in a of 0, we just printed the value. That is why the 10 is repeated here. So the program is working correctly. Next, okay. Next, I am going to check whether the second option, the partially filled one. Okay, 1. So this will directly go to the first position. Then again I am trying to insert a new element 20. 20 because we didn't make any verification here, so that is assume that the element is saved. Okay, so to verify that, I am directly writing a program for display. Okay, void. So display is also having the same property of NQ user-defined function. It is not going to return any value and not going to pass any parameter. Okay, display void display. So what's the procedure? We are going to display from front to rear. We are in this case, two elements are there. We are going to display from front to rear. Front is in the 0th position, rear is in the first position. So what are the elements that we are going to print? First we will print 10, then we will print 20. If we have one more element, then the rear value is incremented by 1, so 2. So what we are going to do is we are going to print first from front to rear. So 10, then 20, then 30. If I am deleting the element 10 here, what will be the value of front? 1. So after pressing the display option, program should print 20 and 30. So likewise, so I am going to write a program for this. So it's a continuous process. We need a loop for from where we have to start. That is important. We are going to start from friend. So I am going to disturb the value of friend here, but I am assigning a variable I equal to friend, because friend and rear are the key player in this program. So we don't want to disturb the value of friend in any other program. Either other than insertion and deletion, we don't want to disturb the value of front and rear. If you made any changes in the value of a front and rear in a display or somewhere, what will happen? The entire program may get collapsed. Okay. So what we are going to do is, I am assigning the value of friend to a variable I. So friend I equal to friend. Then I should be less than or equal to rear. We can move up to rear. We are going to print up to rear. Then I plus plus. I am declaring the value of I, int I. Okay, once we made once we completed the for loop, then printf %d is the control string for displaying the value in the variable a of I. So what will happen? Initially friend value if friend equal to 0, then I is assigned the friend value of friend, so I equal to 0. I less than, in our case, rear value equal to 2, so I less than 2, less than or equal to 2, a of 0, then I is incremented by 1, I value is incremented by 1, so I value will be 2 less than or equal to 2, likewise. Okay, let me check whether the program works correctly. Okay, I forgot to place a semicolon here. So this is a way that you have to write a program. Don't directly copy a program from anywhere and execute. You didn't get any exposure from the program. Okay, you try to write your own program. Okay, expect this kind of errors. But listen, initially it may be tough, but after correcting the programs one by one, by clearing the errors one by you, then you will get a high confidence that you are able to write a program by your own. Okay, you don't want to, you will not hesitate in future for writing a program, because you are so confident on writing the program. So that is why I am trying to write a program like this in front of you. Otherwise, I have another option that I can just display the program in a form of in a PDF or somewhere and just explain. But I am not going to do for that, because I just want to motivate all of you for writing a program by yourself, by doing like this. That is why I am trying. You know, it's time consuming. I am taking too much of time for writing the program here. But my motto is to make you get motivated for writing a program. Okay. The first option is NQ. Enter the element 10. Okay. Then I am again trying to insert a new element 20. Okay. I made a mistake here. Listen. What happened here is I made a mistake that NQ operation, first operation, it collects the value, enter the element, but after the first insertion, if I am trying to insert for the second element, it is not asking for the element. Listen, it's not asking for the element here, because I mentioned these two statements inside this condition, friend equal to -1. So that is not applicable for the else case. So either you can copy this one and paste it here. Okay, I have to stop the execution process. Either you can place it here, or you can commonly place it in somewhere else, like here, so that it will be common to all the two cases. So I am hiding the program here. Hope you understand what I did. Okay, now I am trying to run the program. Okay, enter the element. Okay, it's asking for the element 10. Then enter the, again I am trying to insert a new element. Again it's asking for the element. Now it's working correctly, I think. 20. Okay, again I am trying to insert a new element. Again it's asking for a new element 30. Okay, we entered 3 elements. Just want to verify whether all those elements are saved properly. So press the display option. Okay, display option, what I did is display the elements in the queue. I didn't call the function from the display part. Okay, and just okay, display off. I'm calling the function display in the case 3. Okay, 1 element 10, again 1 element 20, again 1 element 30. So 3 elements I ended. I'm just verifying whether the program, okay, its program is working correctly. So 10, 20, 30. I just want to print it in the next line. So /n, I made it, sorry, /n, 10, 20, 30. Now we are displaying the elements 3. Okay, after display the element in the queue 10, 20, 30. So this is the case. After insertion we verified, and program is working correctly. Next, one more operation is pending, that is the delete operation. So delete operation, I just want to discuss. Here I am having 2 elements 20 and 30. The next available element for deletion is the element represented by the variable friend. So 20. After the deletion, I am incrementing the value of friend to the next position. Here I am going to delete a new element, delete the element. The only available element is 30, so I am going to delete. So after this deletion, we have to make the value as -1, because after the deletion of element 30, the queue is getting empty because no other elements are there. So what we are doing is we are making the value of a friend and rear equal to -1. So this is a special case in deletion. Previously, for example, we have 10, 20, 30. Friend value equal to 0, rear value equal to 2. Assume this is a case. If you are deleting an element, this is a normal case. Okay, what we are doing is we are incrementing the value of friend to the next available element. Then I am deleting the element, then it is moving to the next available element, 2 position. Okay, so this is in this case we have only one element. So we have only one element to delete. So after the deletion, queue is going to get empty. That is a very important thing. So after the deletion of this particular element, we are assigning the value of friend equal to -1 and rear is also -1. So this is the 2 cases that we have to consider before before writing the program. Okay, so write a program for deletion. Okay, stop, void deletion. Listen, delete is an inbuilt function, so you don't use the delete as a user-defined function. So make it as a deletion or a del or something else. Okay, I am using deletion. Or better you can use a word dequeue, dequue. Okay, and this is a void. in the case of a deletion operation, call the function delete, deletion, dq, dque, delete, dq off. Okay, after that it's moving on to dq. Okay, in this case, what is the first step? So in the case of a deletion, what we are going to do is verify the queue is empty. If the queue is empty, we don't have we don't have the rights to delete an element. So printf error message. So that is the first step that we have to follow. If so for deletion, I am using the variable friend. If friend equal to -1, if friend equal to -1, then we can confirm that we don't have printf no element is available for deletion. For deletion. Okay, no element is available for deletion. If the condition is false, then we have two options. Verify whether the queue is having only one element, that we discussed just before. How will we verify? How will we verify whether the queue is having only one element? For example, 10. What's the value of a friend now? 0. Rear is also 0. Now the queue is having only one element. Go through the value available in, that is the variable having 0 in both the cases. Consider I am inserting a new element 20, friend equal to 0, then rear equal to 1. Again I am deleting the element 10, friend equal to 1. In this case also we are having only one element. If the queue is having only one element, then friend and rear are same, friend equal to rear equal to 1. Again I am inserting a new element, friend equal to 1, rear equal to 2. After the deletion, 20 is going to get deleted, friend is incremented by 1, 2. So listen, we are having only one element. What's the status of friend? What's the value available in friend and rear? Friend is friend and rear equal to 2. So what's the meaning of that? We can identify whether we are having only one element by verifying that if friend equal to rear. If friend equal to rear, then we can finalize that we are having only one element. Okay. If we are having only one element, what we have to do? We have to display the element that we are going to delete. Printf deleted element is %d, comma a of friend. We displayed. After displaying the element, we are going to assign the value of friend equal to rear equal to -1. We don't have any other option. After the deletion of the only available element, we are going to assigning the value of friend and rear equal to -1. If the condition is false, okay, then again the same statement, printf the available deleted element is, I am using the same statement, and then I am incrementing the value of friend by 1, so that friend moves to the next available first element. Okay, now we are going to run the program. Okay, 1, 10, okay, displayed. Again 1, 20, okay, again 130, again 140, again 150, again trying to insert a new element, but queue is full. Okay, so insertion program is working perfectly. Now I want to verify display operation. Okay, in display, okay, all the elements are printed from front to rear. Now we are verifying deletion operation. Option is 2. Deleted element is 10, because we don't have any other option that it automatically delete the first inserted element. That is a procedure, that is a concept of queue. Deleted element is 10. Now I am displaying the element one by one. 10 should be removed from the list. Yeah, 10 is removed. 10 is removed from the list, and 20, 30, so we are having only 4 elements here. Then again I am deleting element. Next available element for deletion is 20. Again I am displaying the element. So 30, 40 and 50. Again I am deleting the element 2, deleting the element, so 30. Okay, display the element 4, sorry, display the element 3. Option, we are having only one element. We are having 2 elements, because the last deleted element is 30, I think. So we have 2 elements. Then I am again deleting the element 2. Okay, 40 also get deleted. Trying to display the elements. Okay, only one element is there. So this is a special case to verify whether this program works correctly. So what should be the next? After the deletion of this element, the queue is going to get empty. Okay, trying to delete. Okay, deleted element is 50. Then again trying to delete the element 2. No element is available for deletion. Okay, hope you all understand the program well. If you have any doubts, we will discuss in the live interaction session on Saturday. I am planning for that. I will inform you the link. Okay, thank you.